What is the Lewis structure of xenon dichloride? So, xenon dichloride Lewis structure. So with this, xenon is actually on the 18th column. I can say right away it's going to have an expanded octet because this is one of the noble gases, or at least noble atoms, and they don't even want to form bonds. So the fact that they are, it's anything goes. Well, reasonably anything goes, at least for the xenon. And the chlorine still should follow the octet rules in this case. Nonetheless, we have xenon, which contributes 8 valence electrons, and chlorine, which is 7 each, that's 14. So in total, we're working with 22 electrons. So we're going to put xenon in the middle because it's the only unique one, even though technically it has 0 unpaired electrons. Nonetheless, let's see what we can do here. We're going to have 1 chlorine, 1 chlorine. Fill in the octet for the chlorine because it was sharing 1 of its 7, which is why I was able to add 6 more. Same here, 2, 3, 4, 5, 6, 7. So that's very nice. Xenon, on the other hand, is right now sharing 2 of its 8. So it's going to be 3, 4, 5, 6, 7, 8. That right there would be xenon dichloride. Now we're going to check to see if we actually have 22 electrons. 2 bonds, so 4 electrons there. And we have 3, 6, 9 lone pairs. 9 lone pairs, that's 18 electrons, plus 4 from the bonds. We do indeed have 22 electrons total. Do these abide by like a formal charge of 0? So chlorine, for it to have a 0 formal charge, likes to have 3 bonds, 3 lone pairs, and 1 bond, which is what each chlorine has. Xenon, on the other hand, likes to have, unfortunately, 4 lone pairs, 0 bonds. So then how can we compare these two? The cool thing is that when you turn a lone pair into 2 bonds, you keep the same formal charge. So I can do this. So now I can say xenon can have 2 bonds and 3 lone pairs for it to have a formal charge of 0, which is what it's doing here, which is why this would be the best structure for xenon dichloride. This is indeed the Lewis structure for it. Let's see what our colleague says. 22 electrons, and there we go, right here. 3 lone pairs in the xenon and 2 bonds sticking out of it. So now for question number 15.